Okay, so today I'd like to work on writing some tests. So, um, one of the problems I've been running into lately, right, is that there's like a lot of edge cases that are easy to miss and screw up, especially when it comes to any of the escape code handling. Um, in order to make sure that that doesn't cause any issues going into the future, it's probably better to just write some tests. Um, Now there is like actually a program I've never looked at it actually called uh, the VT test, I think, like virtual terminal test. Um, I think you're supposed to like run this in the terminal and then like you check some other things and see if it's working. Um, Certainly we can look at that once we have something more running. But what I'd like is some more tests that uh, kind of like external to the actual terminal itself. Um, Now the reason even I think that VT test exists is because of the way Xterm is just structured. Like it doesn't lend itself well for easy testing. But the way I've been structuring this code, this terminal.c, which is where all the escape code handling, all the stuff related to the terminal is just being supposed to be getting handled. Of course, we might find that it's not. It should all just be in here. So we should be able to just write a little program here that tests this code only and ignores all like the OpenGL render code and all that stuff. Um, so that's what I'm going to start doing. So quickly, I guess I can just say before I start is there's like kind of two ways to test this. You could just have like some program that you pipe in a bunch of input and then it goes and passes it through all this terminal code and then it decides somehow on what to output. I think that feels like really limiting, even in general, but especially for like the terminal because how are you supposed to just see if everything got parsed correctly without coming up with like some output format and writing a bunch of extra code for doing that? I think what makes more sense is to just write uh, like basically code that just calls into like here, right? Or like obviously first it has to call into the split lines function, but or split raw input function, and it just continues along. So yeah, I'm just gonna start doing that, right? And then you can do stuff like examining the state of like this terminal structure and asserting that it's correct based on the input you just provided. So I kind of like that method more, I think. So we're gonna make a new file here called test.c, and we're just gonna try to get it compiling. So in test.c for now, we're just gonna have our main. And it's gonna have to do a bunch of stuff like allocating, making like those ring buffers and blah blah blah, all that stuff. Um, and then it's also just gonna include terminal.c. So they can call, I don't know what I'm typing, so they can call all of those functions. So first things first is to basically just get this to compile. So probably going to be some reasons why this won't just compile without us doing some tweaks. And we will do that. So let's actually add this file to the build script. We're always just going to build it. I don't see any reason not to. We're not going to run it every time, obviously, but so that's good. Technically, we don't really need to link against this stuff. Um, there might be like a couple functions that will need to be just completely stubbed out here beforehand. Like we don't really want GLFW and stuff. Maybe even it's better to just have like a test LD flags that don't do any of this stuff. I don't know. That's possible as well, I guess. We could have like test LD flags. which are basically just empty, I think. I don't think we need to really link any of this stuff in here. Maybe like libm, but I don't think I'm using any of that right now. Let's just try that, I guess. As far as the rest of the C flags go, it can probably just, I guess this is gonna give some C flags as well. Let's see what this just outputs. Oh, list some like include stuff. Yeah, we don't really want that either. So we'll make our own test LD flags as well, or test C flags. We're gonna do all this. That's all good. You know, maybe we'll find that some of that stuff should be included, but for now, I don't think so. So we're gonna start with that, and let's try building it. So unknown type. So means we're gonna need to include this util.h, which actually includes all this stuff. Probably we're gonna start removing some of these so that they're not included via includes.h because, or util.h. And then some of these types we're just gonna have to define as a stub. So this one, if we go to, let's just zoom in here a little bit. If we go to user include, just search for this. Okay, this is showing up in a couple places. Interesting. I'm gonna do this. We want to look at these ones. So let's cd into free type 2 so we can avoid a lot of junk. And we'll do that again. And really we're just looking for like a type def, which is not gonna so easily show up, I see. Oh, right here. So it's this library rect pointer. It's a pointer to like this library rec. We can just type def it as like a void pointer. We don't really need to include that. So we're gonna do that. We're gonna do a pound. We're gonna do a type def. And we'll have to do the same with like the glfw window as well. So we're not going to be using any of that code, so we can just do this for now. All of this stuff we need. Oh, this is actually including these headers. That's like kind of annoying, to be honest. I mean, we can just include those headers, I guess. It's like not a big deal. Because we're not going to call that code. This one we're not going to include, though. We're not going to be including glfw or any of that. That's fine, we'll do that. And then we're going to do this. Now, the font code, I don't really want the font code either. We shouldn't even be calling any of that. So really, the font code, well, we'll just start with this, I think. So that just means we need to include these those C flags here that we removed. So I think we'll just go back to using the normal C flags for now. I'm not going to be linking any of that. But we'll still need to link against free type. You know what? It's okay. We'll just use the exact same library C flags. That's fine. It's like a bit annoying. I don't really want to link. Yeah, you know what? No, we're not going to do that. Change my mind again. We're just going to do -l free type. Well, here's the thing though, if we just, I feel like a lot of this stuff's going to be optimized out, so I don't know if we even want to, well, okay. We'll do it. We'll do the thing for now. I might think about how to remove that later. And then here we're gonna do this, but we're gonna just remove a bunch of stuff from it. No GL, no GLFW. We'll do that for now. So these functions, I think I should like, I don't really want to move them though. I think probably it would be smart to move these into the GL code, like the terminal stuff with all the other OpenGL code. Um, it just seems like a pointless redirection to do that though. But to be fair, like this function, save title, like we can just like write a stub function for that. Um, yeah, I think maybe we'll just do that. I don't want to move those just yet. We'll think about that. For now, we'll just type that. We'll just stub that out. So we'll do um, void. This is going to take a glfw window pointer. W, and it's going to take a char pointer, C, S, doesn't matter. And it's not going to do anything. We're just going to stub that one out. This one we'll have to actually just, we're going to return a static string anyway, so it's okay. So this one takes the window pointer, and it's going to just return test. So again, you shouldn't free this, so this is perfectly fine. Okay, so let's see what's going on here. So be it, that can be a con. I hate const, but I think the glfw function just returns a const, so we'll play their stupid games. Okay, so passing parameter of type character, we'll play their stupid const nonsense. Okay, so what is that variable? Oh, 'cause we're not in debug. That's a good point. I should. I mean, for the test, we're gonna want the debug flags enabled. Um, I'll fix that later. I'm gonna punt on fixing that issue for now, and we'll just make sure the debug is enabled. Probably all of this. Okay, so that's good. So we can compile that now. Um, let's take a look at that binary here. So we've got a test output here. Bring that over here so you can see it. And we're just going to do an LDD test. And it's linking all the stuff that FreeType would link, but it's not really the end of the world. We might fix that later if I care about it enough, but for now that's okay. So what we're gonna do is we're gonna open up the normal main program and we're gonna see what that's doing to start the start everything up here. So we're not gonna start a child, which means we might have to write some other versions. There shouldn't be any like put chars or anything in that code though, as far as I'm aware. At least not yet. There might be later. But we're gonna want to do the same thing here, where we're gonna do this. Get some memory, get an empty terminal. We're never gonna init the fonts, so we don't need a font paths. We are gonna init a window. Oh, never mind. We're not gonna init window either, I don't think. Does init window do anything that we actually need to care about? Possibly we need some of this stuff to be set. Yeah, let us set some of this stuff up. We're gonna make a little bit of a stub init fake win function. We're gonna write an init fake win. And it doesn't really need to take the memory. Actually, do we need this? Because we're not running the actual program, so I don't think we actually need any of this stuff, right? Like we don't need to know what the like, I don't think there's terminal stuff for querying the window size and stuff. If there is, we can deal with that later, right? Like I don't think that matters so much. So we don't really need to do this either. We're gonna skip that. So we are gonna do the cursor reset, even though we already know all the states just correct, but that's okay. We need to make sure that that just works. And then we are going to allocate these ring buffers because we're going to pass input in and it's going to get parsed. So we do want to do this. And like backlog size and backlog lines need to be defined. The size probably doesn't need to be as big here, but at the same time, it also doesn't really matter because it's not that big. The rest of this stuff we're not doing here. So line buffer alloc, this function so this is like an OS function, but this line buffer alloc is not an OS specific function. Maybe we're gonna just move that one into util.c. Let's move that one into util.c. We're just gonna do that. So we don't have those. Those are both defined in the main file. We're going to define those in util.h as well, I think. I don't want those like in the config necessarily, so okay. So that's going good. So then we have to have some sort of test loop where we're going to loop through a bunch of tests and decide what to do. Now, how do I want to structure this? So basically, at the start, it's not going to matter. We can just run all the tests. But maybe later, you have like 300 tests or something, and you broke one test and you just want to rerun that test only. You probably would like to be able to just specify like the test number on the command line. You can test that case individually. At least that's my guess. So how do I want to do that? You could potentially just have like an array of, you could define like a test function, function type pointer, and you could just have an array of those function pointers that just get called in a loop. And then you can just use your index to get into the function. So, I mean, that seems like reasonable enough to me. Let us do this. We're gonna have a static struct table. Does it need to be a struct? I mean, it could have like a name, but at the same time, there's what's it called? The compiler macro func. There's like this func macro. We don't really need the name of the test if we just call the function the thing of the test, right? So let's not do that. Let's do the function thing. So we're gonna do. Let me remember how I like to define these. It's actually like how Casey defines them in Handmade Hero. That is where I learned it. And I think it is a pretty good way if I could just find the code. Where is the code? Okay, so we are going to do this. We're going to do pound define test fun. You have a name. And this is going to return a bool 32 about success. Or it could return a structure, a test result. Yeah, that's possible, I guess. uh, that could work. I think so. I think that's all right. I need to define this properly though. This is going to return a struct test result. Name. Going to take a terminal pointer and it's going to take an arena. Not T, just an arena. We don't need that, and we're going to do type def. Test function. It's going to be test fun, test fun. Yeah. Well, we will do. Sure, we'll do it that way. And then we're going to have a big old test fun array. Tests. This is going to be defined right above main, I guess. Static. Okay. This is going to go right above main, and then we're going to start writing some tests here. So, what do I want to test? So I think the easiest thing is to just start writing, basic tests that just cover the some of these like things in terminal dot whatever. So we want to so we want to do like, I don't know, probably you want to start testing like these escapes and blah blah blah. Now the other thing is we probably want two terminals. Because yeah, we want two terminals because you're gonna want to like be able to check. So like let's say for instance we have our function here split raw input. This is not supposed to touch anything. This is supposed to modify the cursor state though. Because it needs to keep track of that for the feed line. Okay, we're gonna skip that test for now. We're gonna do one of those checks. We're gonna do stuff like this. Let me think. So we want to do first. Basically, we can test like all of these CSI things. I I don't want to test them in isolation though. I want to test them by shoving some data in and then checking the desired result. So let us start by doing so really H and G are kind of the same thing, but so it's like up kind of depends if you want to test them individually or what you want to do. I mean, we can test them both, I guess. Let's do so we're going to define a static test fun. Test cursor movement. And in this one, we're going to do SA raw is going to be equal to SA of basically I just need to put the escape code that would lead to this. So probably I'm going to want like a macro for doing some of this, to be honest. Let's X1 be a that needs to be stringified, which would be like what's the that's like pace, right? What is what's the code that does that? I forgot. Oh, hi, big Waluigi. I am programming some tests for the terminal emulator. Everything you see here is C. Sorry, I didn't have my chat window following me around. I was looking at a different window. Okay, so what was I doing? Right, so we are just making a test file here because I cannot remember. We could also just do this. CPP. So we're gonna do a oh, this is kind of an annoying way of doing this, to be honest, but we're gonna do it anyways. Slash x1b a. This seems wrong. I think it's like something like this. And we're gonna do escape of h. I'm gonna end of yeah. That was annoying. Shouldn't have really closed that, to be honest. I don't know why that happened. Okay, fine, so be it. Escape of A. X1B paste A. Escape H. So this would be so that's gonna put two of those like right next to each other like that, which is perfectly valid code. So we'll do that. And we're gonna have to define CSI of A, which is gonna be escape of. This is gonna be a little hairy, actually. Does that work? I don't know. We're about to find out. Going deep into the macros. (32, 4H). That would be a valid CSI. So we ended up with some escaped quotation marks, which is not what we want. Actually, that's because of me putting quotation marks here. Just be like that, I think. Looks fine to me, I think. I don't really see a problem with that. It's like perfectly valid escape code to just dump into the program, so we'll do that. We need to get rid of this. S8 of CSI 32.1 and H to 32.2, just so that, because I know how that works. And then we're gonna do that. Do a semicolon, close that off. Then we're gonna have to send that in. So yeah, that's fine. We're gonna send this in through the we're gonna do split raw input to lines. And we're gonna pass in the T pointer that we got. I guess these need to have names. My bad. Okay, so we're gonna do that, and then the cursor can move actually from this, right? So that's kind of like okay, but actually we don't let the cursor move. Okay, we don't let the cursor move. It's only like the the colors and stuff that we let change. So far, so good. We're going to do that. And we're going to take the parse lines for now. We're not going to take the parse lines. We're going to ignore the parse lines. And we're going to... So how do we do this in the old vtgl.c? We don't need to check any of this. Then we do this, don't care about that. We construct this, we call this, then we call blit lines. And that's going to take the arena and the term. And then after that, we should assert, we should do a, let's see, is that what we want? I believe that's valid, and then we'll do result dot I was thinking of doing like more than one of these at once, so but let's just test this first so we can hook up some things. So let's say result dot status equals term to cursor term to cursor dot row equals 37 and term to cursor column equals 1. This should be a 1 here. And then we'll say return result for now. Then we're going to add this one to our list. So this is going to be test cursor movement. And then in main, what we're going to do is whatever. For u32i equals 0, I less than array count tests I plus plus. We're gonna do cursor reset tests I with and term memory. If if result dot status 0, then we're going to do we're going to do a printf. So we're going to need to include up here standard IO. Oh, maybe it's already included, but we'll see. We're going to do printf, and it's going to be %d %s I is a u of %u result dot info. Probably we need a /n. And we're gonna have some other stuff like failure count and we'll do that. We'll do failure count ++. We're not gonna exit. And then we're gonna do at the end here, we're gonna do array count tests minus failure count. Hello, Terrace. How are you? How are you doing? Terrace. I don't know how to pronounce it. I apologize. I apologize. Minus failure count out of failure array count. It's great to hear. I'm doing pretty good. I finished something interesting at work today. Well, I didn't finish it, but got it into like a good state. Declared identical function. Is it func or is it like function? Maybe it's function. So be it. It can be a const. I'm not gonna sometimes I hate const. I always hate const, to be honest. Tests declared as an array of functions of type test function. Shouldn't be a semicolon there. Well, if you don't like your work, there's always, you can always keep an eye out for places to move your job to or whatever. If you want to be like that, so be it. LU LU, LU. Put this over here for now. Tests declared as an array of functions of type test function. Struct test result. I mean, that's... Oh, I get the problem here. A terminal emulator is basically just what I am doing this whole, like, it's what's displaying all of the text on the screen right now. So this is not my terminal emulator. Mine is this one. It's in progress. It can display some text, display some colors, does it like pretty fast. But it's not finished yet, and there's still some bugs to handle, so we're gonna write some tests to help along with that. So let's do test, and let's run test and see what happens here. Breakpoint. Gonna have to run test in the debugger. Really? Wait, why is, huh? How do we even get to that point? A, length 1. Hold on. Oh, oops, I didn't fix my dumb bug. Okay. Okay, that's progress. We need to allocate this frame buffer. So when are we doing that in the normal code? Don't do it here. We wait for like a... This is probably like something buggy in the normal code. So we're already finding bugs. That's good. Always good. I think it's in like the resize. Yeah, that's in the resize. I don't really strictly follow a year, but as far as I'm aware, everything I'm using is from like C11 or lower. And the only reason I like C11 is for anonymous. Well, I guess it also has the atomics. I'm not using the atomics in this program, but mostly it's for like these anonymous structs. Because this lets you do like some really nice things, especially for colors. So if you want like a vector of, you want like a vector for, it could be either X, Y, Z, W, or you can do RGBA and just call it whatever, wherever like in the code, whatever you're using it as is. So yeah, I think we can even try setting the old C flags here to standard C11 and like pedantic. Um, I don't know where like ASM is defined, to be honest. yeah, like anonymous structs are like extremely useful. Um, yeah, I don't really know where ASM. I don't really want to find that right now, but um, yeah, that's fine. We'll ignore that for now. And it was like actually a feature. Like apparently there was like anonymous structures in like the original. I don't have a copy of it, but like the original version of like this KNR C book is like the ASM macro like limited to GNU 11. Like a GNU is the ASM isn't like a GNU extension, is it? I mean, it could be. Yeah, it probably is. Okay, I'm using GNU 11 then. I'm using like a few inline assemblies here and there, so oh well. Yeah, I mean like most compilers support like inline assembly, but um so what we're doing, we were gonna fix that resize. So resize gets called when the frame buffer gets resized. But resize should be getting called at least once at the start to allocate that frame buffer. Oh, really? Oh, if that's the case, let's try that. That actually could be the case. So let's write this in openutil.h, and just up here we'll do like the same thing I just did for this like static assert, but we'll just do it up above. We'll see if that works. Okay, so these functions, um, well, I mean, it seemed to work with just the one set of underscores, but um, it's probably the same thing. Okay, so these functions I'm probably not including the proper header for, even though they're like linked in. Um, let's see here. We should be including time.h. Anyways, I want to rabbit hole on that right now, but I will keep this one around. I'll keep this test around. That's totally fine. I'll figure out the rest of that later so that it can cleanly compile with the standard C11, but for now this is good enough. So resize. Resize. We should do a resize somewhere. We should be doing a resize somewhere else, to be honest. I kind of want to do I might just go back to using like the flag. So I don't know if I ever used it in here, but I think we're gonna do the flag thing. So So here we have some GL flags. We're going to do a needs resize. And we're going to do, what are we calling resize? At the start of our terminal here, we will do we'll do this. If t2 gl.flags and needs resize t. I'm still gonna have to copy this code just into the test function, but that's okay. So we're gonna do this, and this window size was in rows and columns, if I'm not mistaken. So we'll do that in the test program. We will set up a size. It's going to be equal to uv2. Yeah, I think it's uv2, and it's going to be, it's set up like an odd size, but 80 by 120 is the standard terminal size, I think. Or it'd be, yeah, I don't really find I don't find those like keywords super useful because it just takes up like like the bool type in general is like not that useful because it just takes up a whole register anyways, so might as well just call it, bool 32. Okay, so dot width is going to be equal to, I guess it was like 120 by 80. I don't know. For some reason that feels wrong to me. That sounds wrong. Oh, yeah, it is. It is wrong. It's 80 by 24. That's the standard terminal size. 80 by 24. Okay, so that was that. Need resize, finish typing this, so resize. What I'm doing, or equals needs resize. Oops. Okay, so let us build this. Yes, that's the test failing. Let's make sure that the actual program still runs. That's cat, something else. If we like resize this, there's no problem there. This still resizes just fine. So let's run the tests now and see how we get. So more breakpoints. Now for a different reason. That start is just completely wrong, obviously. End looks right, but the start is. The end is wrong as well. What am I doing here? Quit. I want to quit. Oops. vtest.c. So test.c. Let's check main.c. Probably there's like some stupid ordering I'm doing here that matters. Shouldn't be. Am I really gonna step through the test program? I think I'm gonna step through the test program. Boy. One of those days. Let's not do that. Let's break it main. Okay, so we get some memory, get a terminal. Terminal's full of a bunch of junk. Reset the terminal. I should have stepped through that. That's fine. That's fine. Step. Set some terminal state. That's good. Sure, we'll step into that. All of this should be okay. But then this one, what is this one expecting here? So let's bring this over here. This line buffer is fine. Capacity we pass in 1024. Build 0, right at x0. We're gonna alloc out of that arena. Did I that's all, that should be fine. Oops, in the same window. So we're gonna alloc out of that arena. That's gonna give us obviously the start of the arena. Then we're going to assign the start position. Start position is just wrong. How was like this code working before? So start position should be like the start of the ring buffer. I guess that's correct. I mean, that size looks correct to me. We just got like 2 pages that were next to each other. That's kind of expected. Okay, so let's continue stepping then. Stay good. Term size, step into this, because I might have screwed this up somehow. So we need 30K of memory. Started out at 0, so we're gonna increase this needed space up until the page size. So 32K exactly. We will allocate that. We'll get some memory back. There's no cells yet. Then we'll assign cells to this new. Okay. So the alloc size, that's all good. Row size, we need 192 because we're just taking some pointers. So we're going to allocate one page. Okay, that works. Good. Cell count 1920. Is that 80 by 24? I mean, I guess so. I hadn't really thought about it, but it's correct. And the rows are 24. That's correct. Then we're just going to loop through here and assign some start positions. Which is all looking fine to me. Okay. So we're going to call this again. Now, is this where the problem comes from? This wouldn't make sense. This wouldn't give a problem. As this can't give a problem. So we're going to step into this one. So let's see here. So result, test cursor movement. That's good. I see the problem. So this is static memory. This is not read into the ring buffer. We have to copy this into the ring buffer first. Yeah, so that's actually going to be necessary. Yeah, we can just. I think that's fine, to be honest. Let's make a little function here called and this is going to take a and a SA raw. And so this is basically just going to replace the oops, this like read from child function. Probably we want to do like most of this. We can still keep track of unprocessed bytes though. So yeah, never mind. That's fine. So we're gonna do we'll just do the most basic thing, I guess. So I mean, putting an assert here is kind of pointless, but we should assert that raw dot len is less than or equal to rb to cap. less than RB to cap, I guess. For size I equals 0, I plus I less than raw.len, I plus plus. RB to the buffer I equals raw.data I. And then we're gonna do, we don't even need any of that. RB to, we'll just copy some of this stuff here. So the rest of this should be fine. Fine and good. I don't know if it even matters that it returns the size. Yeah, it does. It does matter that. Okay, so what do I do up here? Okay. Let me just see here. So what did we do in vtgl.c? So we did read from child. I kind of just want this to be called, well, fine. Fine. It is fine. Okay, so that is that. We are going to do up here, we're gonna do this. This is going to be copy into ring buff term to RB, what do I call it? Term to log. So that is looking good. Okay, so why did that fail now? What did we actually check? Okay, yeah. Let's try. Let's figure out. Let us figure out why that failed. We need to break it main. Skip over all of this. Don't care, don't care. Step. Copy into ring buff. Let's step in there for now. So ring buff. Cap fill 0, 0. Got some raw data. We're gonna fill that in. Okay. 7. 7, that's fine. Turn 7. But that, yeah, that's fine as well. So now we've got raw in here, which is 7, which is the thing, but it's now in the ring buffer where it's supposed to be. Some of this is gonna get like wrappered up, I think. We're gonna wrap this into some function or macro or something. So I'm not repeating this over and over again, but anyways. So what is the terminal? Cursor 32 or 23. Oh, right, the terminal's not that big. We do not, so let me just open that up. So in this test program, we're not really gonna, well, yeah, we're not gonna exceed the 16 megabytes of data in the ring buffer, and I'm not gonna shrink it because I don't really care if the test program uses 16 megabytes of data of memory. But the ring buffer part, right? The ring buffer, the actual ring buffer underlying this, actually this, there's one thing that's supposed to be fixed here. It should be RB to right IDEX plus I. Yeah. It's just a helper. Because these are going to be like static, and we can't have like a static string. It's gonna like screw up everything else. Okay, so let's see here. Oops, we didn't fix our dumb assertion here, which was to make this go to somewhere useful. Okay, so this is not going to go to this. It will go to 17. And then this will be 16, comma 1. Okay, that's more expected. So do I see how I can just wrap this quickly? Yes, I do. I don't know if that's the best thing, to be honest. Uh, I don't have a better name right now. Launder static string. And we're gonna pass in the terminal, and we're gonna pass in our static string. We just need to delete all that. Wait, don't want to delete that. I want to take that. Take that with me. Okay, we're gonna do right here. Launder static string. I mean, technically, it could. This doesn't have to be strictly a static stir in this case, but that's how it's being used. So Yeah. Okay, that is looking better. Besides the fact that I called these different things, we're just gonna call it that here as well. Oh, duh. Okay, there we go. So, oops, I need to keep running that. I don't just run tests. Okay, so let me. And when I purposely break this again, because I wasn't paying attention last time, um, test failed, 0 out of 1. Um, test cursor movement. Okay. Cool. So let us fix that, and then we will commit this. And then we can start adding other tests. Really, I wanted this to do a couple things. I wanted this to have the G as well. So G, before I commit this, we're gonna open terminal.c, CSI, handle CSI. So G moves something from the, so it takes the current row. We're gonna do the same thing again, except we're gonna do this time G, which is just gonna be, let's say 6, 7G. I mean, technically we don't need to do this twice, but nah, it's fine. And then we'll do Gentiva. I need this. Need that line. 7G. And then we can assert that the column should now be 6 and the row should be unchanged. Sure. This can't be here. Okay, cool. So that's testing 2 separate code paths. That's decent. Actually, it's testing like a bunch of stuff. That's good. More stuff that you test, the better in one test. Okay, so what am I doing? We are going to add some stuff here. So we need to add, let's just open this, close this for now. We need to add build.sh. Don't need to add that. The stuff from main that we shifted around, we do want to do. Do want that util.h looking good. this was just like actually a bug because the only reason it worked on my computer is because my window manager just automatically shrinks the window because it we spawn it at one size and then we shrink it immediately because it's tiled. So that's the only reason why this was working. Are we polling at the beginning of the? Yeah, we're polling before we do anything, so we would have seen the window resize, and then we would have resized it before doing anything else, before going into this the first time. So that's the only reason why that was working. I mean, yeah, you want to do that because if you run this without it running in the tiling window manager and it doesn't resize, then that would have just crashed, which was dumb. One bug fixed. And then let's see here. So we have a few more files here. We have test.c. We're going to look at my git ignore that's not committed. Okay, so we are going to add test.c. Um, cool. So commit that. Pretty good. Pretty good start. Yeah. See here. Maybe we'll add like one color test and then probably call it because I'm like very tired and it's also like 1,000,000 degrees here. I imagine it's 1,000,000 degrees for a large part of North America. So I haven't really looked, but that's my guess. So let us do some nonsense cursor stuff. So set color. We're gonna send it in a bunch of separate commands. Yeah, that's fine. So let's do that. Let us open test.c. And we're gonna do static test test function test color setting. We're just going to do like a combination of all of these in a different sequence. So what do I want to do here? Let's do this. I'm not going to do it in separate blitting calls here. We'll do this for now, but in this other one, we're not going to do that. We are going to do, we're going to do this, and then we're going to do, it should all be fine unless I'm doing something dumb, but this should be fine. So if we do this and we do CSI, we're going to do 8M, and then we're going to do 4M, and we're going to do 9M. And then we're going to clear the underline. And then we're it's maybe getting out of hand, but it's okay. Then we're gonna do we're gonna do two different things. We're gonna do one of these ones. So let's do this. We're gonna do 34, 33. Come on. We're gonna do 33, and then we're gonna do SA raw equals whatever we didn't parse there. And we're gonna do 48. So 48 would be the direct color for the background. And we're gonna do 2. And then we're gonna do just any random color works. So and I believe the not commas, it's gotta be semicolon. Yeah, I believe there cannot be an A. There's no alpha. We're gonna do that. Now technically the cursor, we don't even need to blit these lines to be honest, but we could actually extend this one further. we will just print a character now. Let's print A, doesn't matter, just any random character. We'll do this, and then we will do we're gonna make a cell here. Our cell is going to be how is the cells just defined again? Okay, so the code point A, and then the style is going to equal .bg is going to equal so that's right, and then the foreground is going to equal just copy this actually because this should be present. The foreground is going to equal this. At index 3. And the attributes are going to equal what did we set here? So we did, what was this? So I can actually see multiple things on the screen. We did 849, which would do so I think we did this, and we did 24, which would get rid of the underlined. So it would be 8 and 9. So it's going to be invisible. Have an invisible cell, and it's going to be struct. It's an invisible struct cell. That's our cell. And we're probably going to want another helper function here that's going to be called cell compare. So this is going to return that A to code point equals B to code point, and what's this? And foreground. And the attribute. Yeah, that's looking good. So we can do that. And then we're gonna do here, we're gonna do this would have stepped the column, which is a problem. Oh, we're resetting the cursor every time, never mind. So yeah, this doesn't matter. This will be in column 0. So we are gonna do result we didn't copy the result part. We're gonna do this. Result dot status is going to equal compare cells and C key to frame buffer dot rows key to cursor dot row. It's just be 0, 0. Let's do that. Alright, it should just be this. Yeah. I'm not gonna type that unless the compiler complains to me. Well, complain to me for a different reason. Okay. So now don't need to run that again. I already did that. We need to actually add that to the test list. I think it's time to use the X macro again. Good old X macro. Where's my X? X macro. I don't need to put this test in front of it, to be honest. X macro. Well, to appease my ridiculousness, we're gonna keep it sorted. So what we are gonna do here, we're gonna do found define X A And it's going to do a declaration. It is going to do static test fun semicolon. And then we're gonna undefine x. Undef x. And then we're going to bound define x function to be a function, comma. And we're gonna do tests. We got somewhere in the middle here. This is supposed to be up here. Okay, so let's see here. Did I screw up my X macro? Cursor movement. Did not fix the name. Okay. There we go. So now if we do test, sure, but we got some garbage data. Interesting. What is this? How did we get that? We got this. So where did that go wrong? That shouldn't have worked, honestly. It's just supposed to be this. Okay. Cool. Alrighty, so I can like technically combine all these into one launder static string. But I think I'll leave it as is for now. Let me see something here. Cell. Sure. Why not? Okay, so cool. Let's commit that. Take the next win. So I think that is gonna be it for me for now. I think we could still do the funny thing here, which is the open the fragment shader and edit it from within the terminal emulator that is slightly broken, but hey. And then get our scrolling, our scan lines going. Um, so pretty good. I think that was a good start for the tests. In the long term, I think what I want to do is, anytime we run into like some stupid bug or whatever, we'll throw a test in for it. Or when I want to go and add a new, what's it called? A new like, kind of like a new escape code, can throw a test in, and maybe even before you write the actual functionality, and then you can test it. I'm usually not like the biggest fan of writing code like that though, so I'll probably write the functionality first and then write the test. But um, yeah, so that is gonna be it. Keeping some bugs in the terminal emulator. Yeah, like some of these bugs are like kind of interesting to be honest. I don't really know why they're happening, but I'll have to figure it out at some point. Um, so let's have a look here and see what's going on with the old stream here. So um think we're just gonna call it there for tonight. So as always, thanks for watching, and hopefully I will see you next time. Bye.